What's up, guys? So I wanted to film another video while I was here at school to kind of help you guys out if you're getting stuck on some of the questions that we had for homework tonight. I know this is a tough subject, and I really appreciate you digging in and giving your best effort. Some of y'all have already got the skill down, which is awesome, and we just need to keep it in the forefront of our mind so that we can really master the skill. So these are all what I call, I didn't call it, that's what mathematicians call it. These are all coefficients of 1, which means the leading coefficient is a 1. It's invisible. But these are actually a little faster to factor. For the very first one, I will show the full process, but then for the next 3, I will skip the process and get down to the final answer. So let's jump into it. The first step is to multiply a times c, and 1 times 2 is 2. So our goal is to find two numbers that would multiply to be 2 while adding to be 3. And if you think about 2, it's only going to be 2 times 1. So 2 times 1 is 2, while 2 plus 1 is 3. So I'm going to go back in and rewrite the expression, but instead of having 3n, I'm going to reflect it with 2n plus n. So if you were to put 2n plus n together, you would get 3n. But this is me using 2 and 1. 2n, 1n, that would be 3n. However, the next thing I want to do is kind of do what's called group factoring. N squared plus 2n, they're both divisible by n. And if you take that n off, you get n plus 2. N plus 2 really only has 1 in common as a factor, and so that would give me n plus 2 again. And if you notice, n plus 2 repeated. It was in the first and the second parenthesis, so that is one of my factors, and n plus 1 is the other. Now, what I hope everyone picks up on is the fact that from the puzzle, when we had 2 plus 1 is 3 and 2 times 1 is 2, those numbers were actually a part of the answer, and we could have just jumped to the final conclusion if you understand how they multiply together. So if you multiply n plus 1 times n plus 2, you get exactly what you started with. So I'm going to kind of show that process again, except kind of jumping straight to the answer for these because they're really designed to be worked rather quickly. In the other classes in Algebra 2 and Geometry and further on, they don't go through this full process every time to factor coefficients of 1. They just kind of jump to the answer a lot of times. So this is what multiplies to be negative 10, but adds to be 3. So think about 10 for a minute. 2 times 5 or 10 times 1, and if you're using 5 and 2, you got to make sure that the 5 is a negative, if you had positive 5 plus negative 2, that would be 3, and if you were to multiply 5 times negative 2, well, that would also be negative 10. Sorry, it's kind of hard to write up here at the very top of my board. That's a negative 2. So I can go ahead and say, well, in the first step, the only way these multiply to be a squared is if you had a positive a times a positive a. A times a is a squared. And so we're going to go ahead and use those numbers, 5 and negative 2, and that completes number 18's factors. So why don't you try that for 19 and 20, and I just realized that these are really the same problem. One uses x and one uses n, so my bad on that. I use software to generate the problems. I didn't quite notice that they repeated, so that's on me. Let's talk about some of the ones that are not as easy. These are called coefficients not of 1. And if you notice, the leading number is a 5, or in this one it's a 7. So we really got to think about the process instead of jumping straight to the final answer. So 5 times 6 is 30. We're trying to multiply to be 30 while adding to be 31. And so whenever these numbers are 1 away from each other, I don't spend time thinking about 5 times 6 or 3 times 10 or 2 times 15. I really think immediately about 1 as a factor. So this is 30 times 1 or 30 plus 1. So I'm going to go in and we're calling this Bust the Bee here in Knox County. I don't know what they call it in other counties, but what we're meaning by that is that we want to basically go in here and replace 31R with 30R plus 1R. And then you still have the C value of 6. So I'm going to do what's called group factoring here. If you look at the first two, 5R squared plus 30R, those are divisible by 5. and they both have an r on it. If you're taking the greatest common factor, we would take the r as well, and you would get r plus 6. Now the second two, r plus 6 really don't have any common factors other than 1, so I'm going to do an r plus 6. So the last thing I want to talk about is how r plus 6 repeated, and that makes one of your answers. And then if you notice, you took 5r plus 1 out, and that is your other factor in the end. So 5r plus 1, and then of course you have r plus 6. I want to leave you with 22. Some of y'all on the homework, you did 7 times negative 18 or whatever the problem was. You did a times c, and you knew to add bb, but then you just kind of stopped and you didn't really finish the problem. You need to spend time looking for those values in the calculator. So that's what I want to leave you with, number 22. Multiply 7 times negative 81 and spend time looking for numbers that would actually do that. Okay? I'll do another one. I'll do 23. I'm going to start with a times c. That's 24. Multiplies to be 24, but adds to be 10. So quick little list here. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So if I'm thinking about numbers that multiply to be 24, I got all those here. But the ones that add to be 10, I'm thinking about 4 plus 6 as being 10. So I'm going to use 4 and 6 when I use the next step here. 3x squared plus 4x plus 6x plus 8. So this is what I mean when I'm calling it bust the b. You're rewriting the middle term as 4x plus 6x. Do not put those back together. We need to look and see, well, what do they have in common in groups. Now, in class, I would have discussed would I put 4 first or 6 first. So I decided when I was doing this problem, I want to show you when it is kind of challenging and you're looking at it and you're saying, well, hey, 3 and 4 don't have anything in common. I feel stuck. Well, you're right. They don't have anything in common. However, they both have x. 3x squared, 4x. So I could basically divide each of these by x, and I'd have it out front. And then when I notice the next two, I have a 2 in common, and you see that 3x plus 4, and now you see I'm repeating. Final answer, 3x plus 4, x plus 2. I'd probably see this more often as 3x plus 4, and then x plus 2. To be honest, they're both correct. I think in general we see coefficients other than 1 written first, but there's no specific rule or law about that. So try 24, start with a times c to get negative 240, and then let's see what adds to be 14. I'm not going to do that for you. You should spend time looking for that on your own. So here's 2 on your own. Give those a shot. I will talk about 27. These are a little different. Both of these have v in common, and so if I pull a v off, you have v minus 7. So that is the GCF at work, and honestly, that's kind of it. So you can stop right there. And now I'm really mad at myself because that's the same problem as before. I don't know why I repeated that so many times. That's frustrating. So go ahead and try 29 and 30, along with any other problem that I haven't talked about yet. And please ask questions tomorrow in class. I know this can be a little challenging, and so good luck, and email me if you have any questions.